Internet of Things, applications, and future trends in the process industry. Internet of Things will enable interconnections of billions of devices and physical objects around us with the Internet. These objects will be equipped with variety of sensors to collect different types of data from them. Intelligent processing thus IoT enabler for smart homes, smart industries, and eventually smart cities. It has numerous applications in industries such as telecommunications, automobiles, chemical, petroleum, textiles, and food. This talk will this talk will start with an introduction to IoT, its architecture and working. This will be followed by a brief overview of Industry 4.0 improving productivity at a lower cost with enhanced safety, machine health monitoring, and prognostics. The talk will also discuss various industrial IoT projects that are presently undergoing around the globe and some of the use cases of industrial IoT. Finally, the talk will discuss some of the key challenges that need to be addressed to realize industrial IoT. Our today's guest is going to be Dr. Muhammed Awais Javed. And the Internet of Things. He holds a PhD degree in electrical engineering from the University of Newcastle, Australia, February 2015, and a BSc in electrical engineering from the University of Engineering and Technology, Lahore, Pakistan, in August 2008. From July 2015 to June 2016, he worked as a postdoc research scientist at Qatar Mobility Innovation Center, Doha, Qatar, which is the leading independent for community and cybersecurity. He has published over 60 research articles in the reputed journals and conferences. He is a senior member of IEEE and ACM Distinguished Speaker. Now, without further ado, I would like to welcome our guest, Dr. Muhammad Awais Javed, to take over this webinar and present it.
First of all, thank you for the introduction and thank certain threshold, or for example the car, some part of the car is faulty. So what it can do is it can it can reserve that car, that faulty part on behalf of the car, and it can contact the warehouse and reserve that part on behalf of that car, and the driver can go to that warehouse and get his car repaired with no extra time. So what's the advantage of this whole IoT car manufacturers platform? So it can streamline the inventory. Inventory management by the manufacturer can be streamlined. So similarly, if for example uh, same problem is coming from many cars, then this car IoT manufacturer's IoT platform uh, can basically track the exact location of the problem. So for example, maybe the issue is coming from the exact maybe the parts are manufactured which are faulty are manufactured on the same day or maybe on the same factory line. So exact location of the problem can be tracked. So the overall advantage it can offer is that it can provide safety to the add safety to the car manufacturers. It can provide safer cars, and to the drivers they can now drive on the road faster. So that is one example of a IoT platform. So next I'll move to the industrial IoT. So industrial IoT is basically the use of IoT to improve manufacturing and industrial processes. So the philosophy of smart machines is basically implemented by industrial IoT. So as we know, industry has evolved over the years, starting from industry 1.0, which was about mechanical mechanization, and for example, applications such as steam engines were there. Uh, from industry 1.0, we moved to industry 2.0. So industry 2.0 was about electrification and also about mass production. So we had assembly lines and electricity based machines. So that was industry 2.0. So industry 3.0 was about digitization. So digitization and automation was part of the industry 3.0. And lastly, in the last decade or so, we had industry 4.0. So industry 4.0, the keyword was connectivity. So you had smart technologies such as wireless transceivers installed on the machines. You had computing nodes placed near the machines, for example, to analyze the data. And then you had 5G, for example, 4G and 5G technologies that enabled faster data communication. So industry 4.0 is all about connectivity and faster data rates. So the heart or the brain of the industrial IoT is basically the 5G technology. So there are some key enablers of this 5G communication technology, which provide some benefits to the industrial IoT, which were not present in the previous technologies or previous versions of the cellular communication. So, for example, 5G has four key features that are very much suited for the industrial IoT. So one feature is, for example, the private 5G networks. So in contrast to the normal 5G networks, private 5G networks basically they provide a control to the organization on how they can share their data and what sort of a data should be shared, uh, where it should be shared, among which devices it should be shared. So all this control is provided to the network and IT administrator. So the big advantage is obviously the security, because you want your data, industrial IoT based data, to be secure. So private 5G network is a key feature of 5G that can enable industrial IoT and take it to a new level. Another very interesting feature of 5G is time sensitive networking. So as we know, in industrial IoT, the data is critical. It has time. It is time sensitive. So, for example, the real-time data needs to be shared. So, for this sort of a data, you need time-sensitive networking, which is basically which is also called Ethernet over 5G. So the concept is you want to share your real-time data in a much quicker manner. So techniques such as time synchronization and some packet prioritization are part of this 5G time sensitive networking, so that data can be shared with a very less delay. Moreover, industrial IoT now these days also have some other applications, some new applications, such as, for example, energy optimization of the machines, or for example, predictive maintenance. So for these sort of applications, time sensitive networking is very critical, and you want data to be shared in a much quicker manner. So another key feature of industrial IoT 5G, which is very much suited for industrial IoT, is ultra reliable and low latency. So you want reliable data communication. So 5G provides reliability of the order of 99.999%. So, and a latency of less than 1 millisecond. So data sharing in a reliable manner is a very important requirement for industrial IoT. You want your data to be shared frequently in a reliable manner. So ultra reliable low latency feature of 5G is required for industrial IoT. Uh, Lastly, another feature which is very much part of 5G and which is very much suited for industrial IoT is smart spectrum. So as we know, with the advent of IoT, there are multiple devices, and they have a lot of data to share. So the spectrum is overloaded. So 5G provides smart spectrum management techniques. So as a result, multiple spectrums they can be utilized for industrial IoT applications. So 5G is basically a key enabler of industrial IoT, and in the next 4 to 5 years, when the 5G will be fully standardized, a lot of industrial IoT applications can be realized with the help of it. So, how IoT is used in the process industry? Uh, this will be the part of my next talk. Next part of my talk. So, process industry is basically industries such as petrochemical, food, beverages, and pharmaceuticals. So, these are all the pharmaceutical. These are all the process industries. So, what sort of automation we have in the process industry? So we have some level of automation already existent in the process industry. So this includes, for example, program logic controllers, PLCs we have, and the PLC work. The major work of PLC is to control basically the machines and automate the processes. So PLC is used to automate some of the processes. If we increase the scale, we move to decentralized and distributed control system, which is commonly known as DCS. So DCS is basically a system that coordinates and supervises an entire plant and a lot of varying processes. So it's a scale, higher scaled version of PLC basically. So SCADA is another technology, supervisory control and data acquisition. So SCADA basically supervises and controls the plants both locally and remotely. So it provides a human-machine interface that can interact with machines such as pumps and motors. So this is the existing level of automation already present in the industry. Uh, so what IoT provides? IoT basically enhances the level of automation. So it provides an improved level of automation. Some of the key features of IoT are basically scalability. It provides a scalability in the process industry, for example. So scalability means that it may take long time to set up and get reports from plants that are in different geographical locations. So with IoT, you can share this data, get reports, in a very quick time. Similarly, if you want to establish a new plant, you have all the data in the cloud already there, and you can import that data from the cloud. So IoT basically provides a scalable solution to the industries. The second advantage of IoT in the process industry is basically data analytics. So IoT can gather a lot of data with the help of sensors. As compared to the existing level of automation, you can gather a lot of additional data, lot of actionable data, and you can take a lot of actions, intelligent actions. You can improve the efficiency of different processes. So this is also a key advantage of IoT. The third advantage of IoT in the process industry is communication standards, basically. So devices can talk to each other. They can have communication protocols, and hence they can share data with each other. Different machines can share data with each other in a distributed manner. Lastly, interoperability is also a key feature of IoT. So what interoperability means is different devices or different machines from different manufacturers can talk to each other. So it doesn't matter if one machine is from one manufacturer and the other is from, for example, another manufacturer. They can, they can have some standard communication protocols and they can talk to each other. So in summary, IoT can enhance the level of automation, and it can improve the level of data sharing in an industry. So next, I'll share two use cases of IoT, and these are specific to the process industry. The first use case is an IoT-based heat exchanger. So basically, what is a heat exchanger? So heat exchanger is a device that can exchange or transfer heat from one fluid to another. So it has extensive uses in lot of industries. Such as chemical, power, and petrochemical plants. They all use heat exchanger in one way or another. So it also has applications in oil and gas industry, in the food industry. So a lot of industries, they require heat exchanger. So a major challenge in heat exchanger is basically to improve its efficiency. So how can you make an efficient and a heat exchanger that is operating at a full efficiency? So for that, for example, one idea could be an IoT based heat exchanger, where you have some sensors placed in the heat exchanger, sensors such as temperature that can monitor the cooling and heating of the fluid, and for example some pressure sensors and flow sensors. We can have some measurements like that. These measurements can be sent to a cloud or centralized server, and where some predictive data analytics can be used, and it can be it can be figured out whether the heat exchanger is operating at a full efficiency or not. Some other advantages that IoT based system can offer is, for example, one example is it can prevent fouling. So fouling is basically accumulation of unwanted material on the surface of the heat exchanger. So if you have some unwanted material that is deployed over the time on the surface of the heat exchanger, then this can be detected by IoT. Then this can be detected by a sensor. So, for example, you can have sensors such as that can measure the upstream and downstream flow, that can measure the temperatures, the differential pressures. So you can detect the fouling. You can detect the fouling, and then you can take some measure to remove that fouling and remove that material from the heat exchanger. So the advantage is you can basically predict, based on the data, you can predict the service time of the heat exchanger. So after how much time you may need to service the heat exchanger, you can predict in advance, and as a result, you can reduce the outage time of the heat exchanger. So the advantage is you can reduce the unplanned outages, you can improve the efficiency of the heat exchangers. So another advantage of IoT based heat exchanger is that once you collect data from different heat exchangers, you can compare their efficiencies, and you can maybe pick the odd one out. You can pick the abnormal heat exchanger, the one who is operating at a lower efficiency. So you can pick that one, and you can maybe check the problem with that heat exchanger, and you can figure out the problem. So a big advantage with IoT based heat exchanger is it can provide you some actionable data, and you can take some action based on it. So this is the another example of use of IoT in the process industry is IoT based centrifugal pump. So centrifugal pump is basically a device that converts mechanical energy into hydraulic energy. So it uses basically the centrifugal force on the fluids. It uses the centrifugal force, and they are very popular in the process industry. uh, they are very popular because they are easy to deploy, and they are easy to install. So they have wide applications in the application in the agriculture industry, in the petrochemical industry, in the power industry. So uh, one problem with IoT centrifugal pumps, one problem with the centrifugal pump is that you can have variable flow patterns over the time. So if your centrifugal pump is providing you with a variable flow pattern, then that can disturb the machines, that can damage the plant actually. So you can to mitigate this problem, we can basically detect we can detect the flow. The pressure flow can be measured, and based on it we can find that whether the pressure flow is variable or it is providing us for example a constant pressure flow. So some other sensors that can be very useful in a centrifugal pump could be a temperature sensor that can provide us provide us the inside temperature of the centrifugal pump. So if the centrifugal pump is being heated, or the heat is more than the threshold, then we can detect that. specifically if the centrifugal pump is operating at a low fluid flow. So this can heat up the centrifugal pump. So this can be detected by a temperature sensor, and it can help to find the problem in the centrifugal pump with this temperature data. So some other issues, some other sensors that can be very useful include, for example, the chemical and gas vapors. For example, sensors which detect the chemical and gas vapors. Some liquid volume can be measured. Wear and tear of the there are sensors that can give you the wear and tear of the devices. Then vibration sensors can be installed. Current flow sensors can be installed so that you know what is the current flowing within the right threshold. So all these sensors can basically be installed, and they can be used to improve the efficiency of the centrifugal pump. Uh, as an example, a chemical sensor can be placed, chemical or gas sensor can be placed in a centrifugal pump. In a centrifugal pump, sometimes some chemicals, corrosive chemicals, such as, for example, sulfuric acid is used in the fertilizer industry, for example. So it is very important to contain these chemicals, and stop any flow of emission of these, stop the flow of emission of these chemicals. So because this can damage not only the worker's health, and for example, it can also cause corrosion in the machines. So with these chemical or gas sensors, you can detect these problems, and you can improve the efficiency of the centrifugal pumps. So in short, in summary, the IoT based centrifugal pumps, it can not only improve the efficiency, but it can also predict the maintenance time of the centrifugal pumps. So, in the last part of my lecture, I will discuss some of the upcoming technologies for IoT, and some of the important research directions uh, that can be very useful for the students, for example. So, 6G networks. Currently, the researchers are envisioning the 6G networks for IoT, for a massive IoT applications. So while 5G was all about enhanced mobile broadband, it was about ultra reliable low latency communication (URL LLC). It was about massive machine type communications. 6G provides some very interesting new applications. So which are very data intensive applications, but they're very interesting applications with a lot of automation involved. So applications such as augmented reality, virtual reality, autonomous and connected drones and vehicles, and intelligent automated machines can be uh, realized with the 6G networks. So what 6G networks rely on? They basically rely on terahertz communication. So while 5G was using sub 6G gigahertz or millimeter wave communication, 6G networks are basically using terahertz communications. So the big advantage of terahertz communication is that they can provide data up to terabits per second. So you can have very high data rates can be achieved with 6G. And obviously, all these applications, intelligent and automated machines, and all these applications, they would require data rate of order of terabits per second. So so this high data rate can be provided by 6G. So the latency that we talk about in 6G is about less than 1 millisecond, and reliability is 99.9999%. So it's a very reliable system. Obviously, reliability is very important for these applications. Data is periodically transmitted from machines to the cloud server, and this data is very critical, and it has some time sensitivity. So reliability holds the key, and latency and reliability, they hold the key, so that you can meet the quality of service requirements for industrial IoT. So this slide basically summarizes the key features of 6G. So all of the students, for example, who want to work in IoT, they can basically use 6G networks. want to have want to research 6G and want to explore the use of 6G in industrial IoT, is the right time to explore 6G, because researchers are now exploring all these key enabling technologies of 6G. So 6G basically provides key features such as, for example, advanced connectivity. It provides some novel physical technologies, and it provides advanced artificial intelligence techniques. It also provides energy efficient communication, energy efficient computing, and energy harvesting techniques. So all these techniques are basically part of 6G. And lastly, it provides massive IoT support. So with as we will improve the communication data rates, we'll have some massive IoT applications in the future. So all these applications would require 6G, and so 6G will provide massive IoT support to all those applications. I'll discuss all these key features of 6G, and all these areas are basically under exploration, and researchers are basically working on this area. So this provides some very interesting open challenges which researchers can work on, and in the next few years these challenges will be extensively worked on. So it's the right time to explore all of these challenges now. So the first key feature of 6G is basically massive connectivity. So massive connectivity means ubiquitous connectivity, connecting all the devices, and with, for example, all the devices, all the small computing nodes, the cloud servers, all these should be connected with high data rates. So terahertz communication is the key technology here. Terahertz communication will provide extreme data rates, high data rates, and will provide extremely low latency. Uh, so one important aspect which needs to be investigated is that terahertz communication has a low communication range. So the communication range aspect needs to be figured out. What sort of a connectivity it provides, what sort of a coverage range it provides. So that is something which should be investigated. So while it provides high data rates, its communication range, connectivity range, it should be explored. Another interesting technology is basically a novel physical layer technologies in 6G. So 6G will have technologies such as full duplex communication will be there. So that will obviously double the data rate. I mean, if you can use full duplex for communication, you will have big advantage in terms of the data rate. So full duplex communication is a very important technology. Then channel estimation, advanced channel estimation is an important technique to enable, for example, reliable communication. Channel estimation is a very important technique in it. So advanced channel estimation techniques can be established. A very interesting technique which is very popular these days is intelligent reflecting surfaces. So the concept of IRS is basically they are it is shown in this figure. The concept is shown in this figure. There's they are basically artificial passive elements. So basically they can reflect the incoming wave, and they can reflect those incoming wave with certain phase and magnitude towards the receiver. So in normal communication, in 5G communication, for example, we have a lot of issues with connectivity. We may have issues with communication range. So as I discussed in the terahertz, for example, you may have issues with the communication range. So IRS is a very important technology that can extend the coverage range for terahertz, for example. So the concept is they can basically mitigate the blockages. So for example, in this scenario, the scenario shown in this figure, if a car, for example, car connected with a transceiver, it is trying to communicate with a base station. So you may have some blockages in between. For example, a big truck is passing, so it may block the wireless signal from the vehicle to the base station. So intelligent reflecting surfaces, they can basically overcome this problem. It can provide line of sight communication. So the concept is the incoming signal is basically reflected with a certain phase and magnitude towards the receiver, and as a result, you can overcome these blockages in a wireless system. So these small passive elements can be installed, at different locations, for example, along the road or inside the buildings even. So as a result, they can provide enhanced connectivity. So uh, advanced physical layer technologies will be a key part of future 6G communication. So another interesting feature of 6G is basically advanced artificial intelligence techniques. So we will have AI empowered autonomous systems in the future. So currently we are currently using centralized learning models. So there's a centralized server which collects all the data, and it makes some actionable. It collects all the actionable data and figures out what's the best based on this data. What's the best we can do based on that data. For example, we can control the process. What's the best process control? For example, in the process industry, we can control the process efficiently based on that data. So currently, we're using the centralized learning model. So now the research is going towards distributed learning models. So as an example, a very popular technique these days is federated learning. So in federated learning, basically, the goal is you have some local computing machines. They basically implement local machine learning models. And local machine learning models are basically implemented on these localized machines or localized edge servers. You call them edge servers, for example. So the big advantage is the privacy of data. So your data will only be shared. The devices will only share data with its localized edge server, for example, not with the global edge server. So another advantage is uh, it takes a lot of time to train a global learning model, and the complexity of the algorithm becomes very high. So with federated learning, you can have local machine learning models, and only those parameters can be shared with the centralized server. So instead of sharing all the data, you can share your model data with the centralized server, and the advantage is you can have improved global learning models. So uh, the global learning models can be developed with federated learning. So another key feature of future 6G networks is energy efficiency. So energy is basically a very important concern, because all the computing nodes which are installed near the devices, they are battery operated. So they have energy constraints, obviously. So to overcome this issue, you need energy efficient, not only energy efficient communication techniques, but also energy efficient computing techniques. So, for example, at a device, you will need maybe a intelligent transmission power control technique, maybe a intelligent battery management technique. That, for example, how much power it should be taken for transmission of the data, and for example, when the device can be go into a sleep mode, adaptive, wake up time can be developed, for example. So low power efficient communication is very important for a 6G network. So protocols need to be developed which can enable low power communications. Similarly, energy harvesting is a very important technique where renewables, with the help of renewable energies, or for example with the help of RF energy even, devices can harvest energy. So you need to establish efficient energy harvesting protocols. So for example, a big challenge is uh, how you can harvest energy and transmit energy at the same time. So, or what time you can switch to the harvesting antenna, and for example what time you switch back to the transmitting antenna. So energy harvesting has a lot of challenges and a lot of opportunities for developing intelligent energy harvesting protocols. Similarly, energy efficient computing is a very important technique which needs to be developed. And the concept is basically the devices, basically they they will have their computation power is obviously low, so they will share their tasks with the small computing devices which will be installed, which are known as in the computing term they are known as fog nodes. So fog nodes will basically compute will get the tasks on behalf of those devices. So devices will offload these tasks to those computing nodes, and they will basically compute the task. They will do all the computation, and then they'll only share the result of the task back to they'll share with the device. So energy efficient task offloading techniques need to be developed. The goal is how you would, which task you will offload to the computing device. And at the computing device, the big challenge is there will be so many tasks that will be coming. So how you will prioritize those tasks? So which task will be which task will be computed first, and so on. So all these challenges come under the umbrella of energy efficient computing. Another possible research direction is basically CPU based frequency scaling. So once a computing node has a high load of tasks, it can basically adapt its frequency. So for example, if you reduce the frequency of the computing device, then you are obviously handling less tasks per second, but you are also conserving the energy. On the other hand, if you are you increase the frequency of the CPU, you are obviously computing at a higher rate, but the disadvantage is that you are consuming more energy. So adaptive frequency scaling techniques can be established that can take data of the current load in the network, current computing load of the in the network, and they can adapt the frequency of the computing CPUs. So this is one possible research direction in this area. So another key feature of 6G is basically massive IoT support. So for with lot of applications of IoT, you will require accurate sensing. Accurate sensors will be required. An interesting thing is that sensor selection is also a very important aspect of IoT. So you can have different sensors for different applications. So or for example, for a single application you can have different requirement of a sensor. As an example, if you are trying to monitor the temperature, and your application is to monitor only the air temperature, you may require a cheaper temperature sensor, and that would work for you. But if you are monitoring the temperature in a refrigerator, for example, in a refrigeration setting, for example, or for example in a heat exchanger, you're trying to measure the temperature. So that temperature sensor would be different, and that should be more resilient, and its working would be different. So accurate sensing is a very important aspect. Similarly, not only in industry but also with healthcare, you would need a lot of accurate sensors, and accurate sensing is a very important aspect. Similarly, accurate localization is very important, especially with supply chain industry. For example, you with supply chain industry, you want your products to be installed with sensors so that you can measure the location of your current the location of the products. So for example, whether the product is in the warehouse at the moment, whether it is in a truck at the moment and traveling towards the client, or all these sort of things, you want to measure the exact location of uh, uh, the product in the supply chain. So accurate localization techniques would be required. So all these challenges would be the key features of 6G, and they are still these challenges are not they require a lot of further research. So these are all the challenges which can be worked in the future 1 or 2 years. A lot of work can be done in this area. So finally, I'll summarize the open challenges of this talk, or related to industrial IoT in the industry, use of industrial IoT or IoT in the process industry or any such industry. So we'll have connectivity is a major challenge. You'll need higher data rates. You'll need reliable data communication. So 5G is currently under the process of standardization and under deployment. So people are also investigating, researchers are also investigating 6G. So connectivity is a very important challenge that can be looked upon. That can be looked on. So security is another challenge. So you need your data to be shared in a secure manner. So for that, there are some advanced cryptographic techniques, maybe based on digital signatures and maybe even a physical layer security is also currently used for security techniques. So advanced security techniques will be required so that your data can be shared in a secure manner. Thirdly, fog computing is a important challenge. So as I discussed earlier, there will be small computing nodes that will be placed near the end devices. So efficient fog computing protocols, deployment of the fog computing nodes, and how the task offloading will be done. So all these challenges need to be investigated under fog computing. Lastly, the biggest challenge is data analytics. So with all this connectivity and all these computing capabilities, now we have a lot of big data and capabilities to analyze this big data. So now challenge is how we can convert this data into useful insights. So useful insights that can improve the processes actually. So we have the data, now we need to convert it into we need to have some useful insights that can actually improve the efficiency of the system or efficiency of the industrial processes. So I'll end my talk on a small quote from a British economist, Nobel Prize winner Ronald Soos. So he said that if you torture the data long enough, it will confess to anything. So the goal is not to torture the data and analyze it properly and gain some useful insights that can actually improve the processes. So here I end my talk, and the floor is now open for questions. Thank you.
Please raise your hands if you have any questions. The mics will be enabled.
Assalamu alaikum, sir. Hamza Safdar, Vice President, GCU-ACM Student Chapter. Sir, मेरा question Internet of Things में research careers के हवाले से था. इसमें students के लिए कौन सी ऐसे topics हैं जिनमें research कर सकते हैं? What do you suggest from your what would you suggest from your experience?
So, as I discussed के IoT में basically जो current research challenges चल रहे हैं वो 6G से related हैं. So अगर किसी ने IoT पे काम करना है तो 6G especially in the communication side 6G में काफ़ी key enabling technologies हैं जो new technologies हैं जो कि जिस पे अभी काफ़ी काम बाकी है. स्पेसिफिकली इंटेलिजेंट रिफ्लेक्टिंग सर्फेसिस हैं, उन पे काफ़ी काम है कि उनका डिज़ाइन किस तरह से होगा, वो किस तरह से यूज़ होंगी फॉर एग्जांपल. इसी तरह कंप्यूटिंग में जिस तरह से मैंने कहा एनर्जी एफिशिएंट कंप्यूटिंग जो है उस पर काफ़ी काम है कि हमारे कंप्यूटिंग प्रोटोकॉल्स क्या होंगे, एनर्जी एफिशिएंट प्रोटोकॉल्स क्या होंगे. सिमिलरली जो मशीन लर्निंग मॉडल्स हैं, फेडरेटेड लर्निंग जो है एक बड़ा इंटरेस्टिंग है आजकल कॉन्सेप्ट है जिसमें आप डिस्ट्रीब्यूटेड मशीन लर्निंग की तरफ जा रहे हैं और डिस्ट्रीब्यूटेड मशीन लर्निंग से आप वही प्रॉब्लम सॉल्व करने की कोशिश कर रहे हैं. सो ये कुछ चैलेंजेस हैं जिनमें काफ़ी ज़्यादा चांसेस हैं आगे काम करने के लिए भी, और क्योंकि बड़े रीसेंट चैलेंजेस हैं तो इसमें स्पेसिफिकली रिसर्च के एंगल से इन सारे एरियाज में जो है काम किया जा सकता है.
Now we would like to ask any of our attendees, please, if you want to ask any question, raise your hand. Our stage team will enable the mic. Then you will be able to ask a question. Any question? Okay. Okay, then I think, sir, we have no questions from. Just a second. One question from Mohammed Shahid. Kindly open the mic. Abdullah, open the mic, please.
I have opened the mic. He is allowed to speak now. Shahir, you can unmute and ask your question. You are allowed to speak.
Sir, thank you very much for joining us today here at All Pakistan Tech and Art Festival. It was really informative talk, and we all, on behalf of executive team and GCU-ACM student chapter, I would like to thank you.
Thank you very much for inviting me, and great.
Thank you very much.
Thank you.
Kindly proceed with the attendance. Sahil, are you there? Sahil?
Just a second, Hamza bhai. I am presenting the slide for the attendance.
Here are some messages from our collaborators that I would like to present first. These are some messages that our collaborators have written for us. NUCES Peshawar Student Chapter. ACM is a gateway for providing skills and dexterity that are needed to thrive in the modern world. NUCES Peshawar ACM Student Chapter, found in 2014, serving as a gateway and opening doors to possibilities, bring the best on the table. Helping us achieve these goals are our talented members who work tirelessly with the best of their efforts. Our purpose to expand ourselves into the horizons. Sorry, one moment, please. Sorry for the interruption. Now for our proud partners. Now for our proud partners, NUCES Peshawar Student Chapter. Sorry for the interruption before. ACM is a gateway for providing skills and dexterity that are needed to thrive in the modern world. NUCES Peshawar ACM Student Chapter, founded in 2014, serving as a gateway and opening doors to possibilities never seen before. By providing the necessary tools and environment, we aim to bring the best on the table. Helping us achieve these goals are our talented members who work tirelessly with the best of our efforts. Our purpose is to expand ourselves into new horizons as NUCES Peshawar ACM embark in mutually sharing knowledge, sustainable passion, and unforgettable experience. Our mission to create an environment that caters to an individual's personal interest with a connection for growth, nerve-wracking competitions, and a warehouse of resources. A predicate to have our members move beyond subject matter and explore a world of nuances involving the integration of computing with industry and research to be a career-ready student. Our expedition to push boundaries as we grow and develop a community with a single driving force, passion. Passion for programming, problem solving, research, and team engagement. Few of our recent events from past 2 years are Youth Social Entrepreneurship, G-Night, our signature event, full night e-gaming event, Tech Khyber Pakhtunkhwa 2020, Coder of the Year, Code Wars, Flutter Workshop, Master Git and GitHub Workshop, WebDev Complete Roadmap, Seminars, AISEC, IELTS, Social Communication, Co-Curricular, Bonfire, Concerts. ACM always keeps things going in motion. From Tech KP to seminars, we always encourage a friendly and strong environment for all students. The chairperson's message is, as the world is revolving around technology and skills, one must be prepared to stand on our own. I need to adapt to this culture. Now, since I am chairperson and hold my own, I need to adapt to this culture. Now, since I am chairperson of ACM, I believe I wouldn't have got here if I wasn't an active member. I urge you to discover the hidden you, and the best way is to start from somewhere. NUCES Peshawar ACM Student Chapter will provide you this amazing opportunity. Ahmed Tariq, Chairperson, NUCES Peshawar ACM Student Chapter. Our next collaborator is Arbisoft ACM Chapter. Arbisoft ACM Chapter is one of the active professional chapters of Pakistan. Arbisoft is revered as the industry leader in the IT sector and actively looks to partner with other institutes to tackle contemporary industry issues. One of the growing concerns is the lack of quality resources available for the industry, and the major reason is the gap between academia and industry. Suppose of this chapter is to bring the gap Suppose of this chapter is to bridge the gap between industry and educational Our next collaborator is UET Tribune. UET Tribune is the first ever magazine-style news web network and the largest official media group of University of Engineering and Technology, which aims to bring news, information, alertness, awareness, and social aspects of the institution with its unique style of journalism. Founded in 2015, at the time it was only and fastest growing infotainment-based media group that has chapters in all affiliated campuses of UET. It covers all on-campus and off-campus ongoings, events and activities, and represents UET on a national and international level through its platforms of social media, including Facebook, Instagram, Twitter, etc. UET Tribune is also well known for covering, publishing, and acknowledging the success and achievements of alumni of UET. Its significant projects includes LUMS Tribune, PTUT Tribune, 1 Minute UET, etc. It covers several notable domains of the institute, primarily being campus seminars, history, welcome, life and style, sports, travel, and many others. UET Tribune is considered to be the most authentic and reliable source of information for all UTians. This was the video from our collaborator, UET Tribune. Our next collaborator is ACM and sorry. IEEE student chapter. Everyone, please get ready for the attendance.
हमजा previous link में हमने खोल के करना है attendance.
Sorry for the miscommunication. There was a video of the IEEE student branch, NED. Okay.
All right, everyone, kindly pay attention. It is time for attendance. Uh, a slide will be displayed, uh, which will contain a link. You have to type that link in your browser, and there you will be greeted with an attendance form. As you can see on screen, this is tinyurl.com/GCU-ACM362. You have to dial it on your browser, on your phones or your laptops, doesn't matter. लेकिन एक बात याद रखिएगा कि आप Gmail ID से अपनी login होने चाहिए, otherwise you won't be able to fill this. क्योंकि सिर्फ एक रिस्पॉन्स एक बंदा फिल कर सकता है। 5 मिनट्स हैं आप सबके पास। tinyurl.com/gcusm362 क्रोम पे आप कर सकते हैं, इंटरनेट एक्सप्लोरर पे कर सकते हैं, जो भी मोड आप यूज करना चाहें। इसको टाइप करें, अपनी डिटेल्स फिल करें, जैसे ही आपने रजिस्ट्रेशन फॉर्म में की थी वैसे ही आपने अटेंडेंस में कर